Would you like to learn how to design complex user interfaces in React Native and using Flexbox properties for parent and the child views easily? Join me in today's video to learn how to move the element in our views with implementing minimum number of codes, positioning the views in their containers with the flexDirections, alignItems, and justifyContent. Also, we will learn alignSelf and the flex properties. So cannot wait to start this video. So let's get started and create the project in Visual Studio Code. The command is npx create expo app, and you don't forget to use the template. Select a blank template to give you the minimum code and give it a name and wait for a couple of seconds. The application should be ready to start. Here's the app in my Visual Studio Code after finish creating and all downloaded node modules. Now to start with Flexbox, I need to start with parent flex properties and then go to child flex properties. In order to test that, I will design a simple user interface with the 3 views in order to see different colors and how those views are working with flex properties. Now in this way, I can test this application right now and see the initial setup. Don't forget that I have alignItem justifyContent to be center. I will clear everything. I just need flex to be 1. I could also remove it for now. I need to see the application as is without any pre-existing flex properties. So I will run this application in npx expo start, and I will try it with my Android Emulator. Android Emulator already running, so I will test my app in that emulator. I could also try to run it in the web. If I run the command, there is missing dependencies, I should install them and should be ready to run in the command in the web browser. Now this is here my initial application. As you can see, I have 3 text in those 3 views in the top left corner, and they are stretching all the way to cover the width. Now I cannot see the main container, so the container that contain all those views is actually stretched to fill the space. So in order, and it is white, in order to see that, let's say here I need it black, I could here just try here to give it a little bit of this. It is a black, but it is already under the 3 boxes, so I cannot see this black. So I will give it a little bit of width and height. Do you know what? Let's only give it some height, so I can here see, let's say 400. And if I save, here we go. This is the black background underneath those 3. I will put it back to white. But I will give it some border, so border color, I will give it some border color to be black, and I will also give it some border width, let's say 2, so we could see a border around that view. Perfect. This is exactly what I need to see. Now to start with the first attribute of flex, let's look at parent flex properties, which is a flexDirection, and I will implement that to the parent of this view that I have. So I will keep here the emulator to this side. By default, flexDirection is column. So if I try here to change it to row, look at what will happen right now. I will save it and all good. I see the 3 views or that contain 3 text in 1 row beside each other. So column flexDirection is the first attribute. I will right now stick with column to cover the following properties, and then we will switch to row to check the following properties as well. So the second properties we will test it right now is alignItems. alignItems by default have the value of stretch, where each element in the container will be stretched to cover the available space. I could change that to be flex start, so all views will wrap their content to the starting of their parent, flex center, where it is to the middle of the available space of the center, available space of the parent, or flex end, where they will be moved to the very end of their parent. So align item, moving those views in a horizontal alignment. So from left to right, I could look at the items from left to right. So let's here implement that to our views here. So we tested so far with column, as I mentioned earlier, so that's why I will do it here with column as well. So as you can see, by default it is a stretch. So those are three views, three child views spread to cover the available space in their parent width. Now if I try here align item with the value to be stretch, we should continue to see the same thing. If this is a flex start, we will see them to the left side of their parent, wrapping their content. And if this is flex end, we will see them move to the other side of their parent, to the right side. And if this is center, we should see those views at the center of their parent, as you can see in the emulator. Now this is all done from between left and right because the flex direction is column. But if flex direction is row, I will do this one more time for row. So if this is a row, as you see, by default they are stretching to cover the available height of their parent. And if I try here align item, by default it is a stretch, as you can see here. If I make it here flex start, they will push to the top of their parent, wrapping their content, as you can see. If this is a flex end, they will move all the way to the bottom of their parent. And if this is center, they will be placed to the center of their parent in this vertical direction. So flex direction is row. So align items work up and down in this container. That's completely opposite to what we see for column. And the slide here provide those examples. So if this is column, I will see the element moving left to right. But if this is a row, I will see the children of this container moving from top to bottom of their parent view. So after finish align items, let's move on to another parent flex properties, which is justify content. For justify content, we can locate or position the child element in their parent in another way of direction. So instead of, and this is also going to work very close with flex direction. So if flex direction is column, I could work with justify content in many different values. So I could go with flex start, where the position, where all elements are to the top of their parent, flex center, or center when they are to the center of their parent, and when this is flex end to the bottom of their parent. By the way, here I'm keeping align element to be default value, so they are, as you can see, stretched. There is one more or two more values for justify content, which is here space between and space around. As you notice, in this specific property, justify content, working with column as a flex direction, the child views are moving in a vertical alignment, so top and bottom of the container but in different positions. So this is here space between, so I have here spaces to before the beginning and after the element, space this is the space around, sorry, this is the space between, so they are cover the available space, no space outside. And this is here to the end, this is to the center of their parent, and this is to the top of their parent or start of their parent. And in all those examples, I have align item to be default value stretch. Come back to the code here. Earlier we had align item to be center, so if I remove this line, align item right now will be stretch. So as you can see, those are stretching to cover the space. I will start now with column. and this is here to the top of their container. So we could here start testing the other attribute, which is justifyContent. And justifyContent by default, as you can see, it is flexStart. This is the default value. So if I try here with the center, they will move in this vertical alignment to the center of their parent. And if this is here flexEnd, they will move all the way to the bottom of their parent. We have also two more, so space between, where I could see those three children spread, leaving space between them, and space around where they are spread to leave spaces between them, and also keeping spaces to the top and the bottom of their container. Those are the values for justifyContent, and with flexDirection to be column. And this is the opposite directions will be implemented when we have row. So if I'm working with the row, I will come back to the slide here. If we are working with the row, for justifyContent, the element will work in this way in the horizontal alignment. So row, this is here row with alignItem to be stretch, as you see the default. flexStart, they are to the beginning, the very right side of their parent. flexCenter, they are at the center, and flexEnd, they are to the very end of their parent. Space between and space around. And this is for row direction. So row direction, row here, the element for justifyContent working left to right, and they are working in this horizontal alignment. So let's here check that in the code. So to check that in the code, here we go, and let's also look at this. I will here change this to row, and I will remove justifyContent. So by default, I have by default alignItem is stretch, and justifyContent is by default flexStart. This is the default values of flexStart. If this is a flexEnd, they will move to the very left side of their parent, and if this is center, this is they are here in the center of their parent, and we have also space between and space around. So this is the space between, and this is space around, and I'm saving here, and this is exactly what I'm expecting to see. So in row direction, they are moving left to right. In column direction, they are moving up and down, right? And this is all for justifyContent. The opposite directions for alignItem, we already covered it earlier. So let's right now move to other type of properties. And this time the properties we will cover are child flex properties. Child flex properties, we will start with flex as the first value. This is implemented to a child element only, not to the parent. It could also implement it to the parent, but I will focus now on a child flex properties. So if we take a look at this example where I have the flex direction to be row, and as you can see also alignItem is default value, they are stretching all the way. If I implement the flex to be equal 1 for the green view, the green view, as you could notice in this example, stretch to cover all available space in its parent, leaving the minimum space for blue and red to wrap their content, but the green one stretch to cover the available space. We could also here take another example where I am implementing flex to be 1 for blue and green views. Here I'm trying my best to make sure they are sharing the equal space, but this is actually the truth. They are sharing right now the equal space, equal available space for in this view. So that means the red view will wrap its content, but the other two views, because they have flex equal to 1, they will equally share the space, the remaining space in their parent. This is here I'm working with the row direction. Same thing implemented if there is column direction. Flex equal 1 for the green, so it's bigger, taking the space. And here as well, if this is column flex direction, here I have a different example where I have flex equal to 2 for green equal to 3 for green view. Here I do different calculations. So 3 for green view, 2 for blue view, and I will also add 5 for red view. This is here just an example to explain a little bit another ways of how can we do that. When I have red for red, 5 for red view, that means in total I have here 5 plus 3 plus 2 equal 10. So this is the layout will split the space based on this percentage. So the blue view will take 2 out of 10, the green view will take the space 3 out of 10, and the red view will take 5 out of 10, which is half of the available space in their parent. So let's go ahead and check that in the example. To test flex property right now, I will remove here justifyContent and just all values for flex, and I come back right now to the default values of flexDirection to be column, alignItems spread, justifyContent top. Now I will work a little bit with other views. So I will go to the green view and say flex to be 1 for that view. If we save, as you could see, the green view stretched to cover the whole available space in their parent, as the example showed us earlier. And let me just also move a little bit to here so we could see, we could play around with flex. So if I have here flex for red view also to be 1, I could here save, and now as you can see, red view and green view equally shared the available space after taking some space only for the blue view. And that if I need the 3 views to share the space equally, I will go here with the flex to be 1 for my third blue view, and that's the result, which is very important attribute. We will use it when we need to split the space equally. If I need some percentage, let's say the blue view to be take half of the space, and the other 2 green and red share the space in a different percentage. So this could be 2, and this is a 3, and this is 5. So here I have in total 10. I will save now, and this is the expected result. Blue view have half of the space, and red view has only 2 out of 10, and this is a 3 out of 10 for flex values, which is exactly what we are expecting. If this is not actually work with direction, it will be implemented to the opposite way. So if this is here row, we will see the same thing, but this is to the row direction. So this is for flex as a child property. We do have another child property, which is alignSelf. alignSelf is a child of flex properties. I could use it for 1 children in my container, and this alignSelf could change the align item for the parent for 1 view of my views in 1 container. So for example, the example that we see it in here, when I have the green view to be alignSelf flex end, this green view actually ignoring the default align item, which is a stretch, and align itself to the end of its parent, which is sometimes we really need such things. alignSelf could be flex start. This is also moving the green view only to wrap its content to the top of its parent, so it's not anymore stretching, similar to other 2 views. Could be center as well. This is if the row is flex direction is row, and here if this is column, we will do the same. It will do the same effects. So alignSelf help 1 view to ignore the default values of alignItems of the parent container. So let's test that here, and that's here in this example. I have alignItem for the container. So alignItems for the container, by default it is stretch, so by default it is a stretch for all of them, which is as you see in here. Let's say I need the green view to be to the bottom, ignoring the stretch align item value. So I could say here alignSelf, and alignSelf I could specify it to be, let's say, center. All good. If this is flex end, and this is to the bottom of its container, ignoring align item to be stretch. And this is could also apply to all other views. So for the red view, I could say here align item, let's say it is center. And for the red view, align item to be center, sorry, not align item. Align item for the red view, making the text in the center, but here I need align self, sorry. Align self to center, and this is to the center. And I could also do the same thing for align self for the red, for the blue view to be, let's say, flex start. And this is the final result of this user interface with 3 different positions or 3 different alignment for those 3 views based on align self properties. By the way, because I already make it by mistake, I will just show you here align item for a child properties. Let's say this is center, and here I'm applying this for a green view. So if you take a look to this green, the content, the text of this green view, it is to the left side. Here I change it to align item to be center, and after saving I could see the text to the center of its view. And this align items usually done or usually works very well with parent, but it's also implemented to child attribute to align the content of that view. And that's it for available or for flex properties we cover today in React Native. Thank you for watching.